Join fast. Please inform everyone and ask them to join fast. The more we delay, the more time we waste. And okay, by lacking some concepts. So please do join on time so that we can start the courses. How many of you have completed the courses? Guys, please do complete the courses. Like the course, the certificates will be based on the courses only. If you are not going to complete the certificates, you are not going to, if you are not going to complete the courses, you are not going to get the certificate. Then what is the purpose of this whole program, right? The main purpose is to give you the knowledge along with the certifications so that you can showcase something in front of recruiters, right? If you are not, doing the courses, it will, at last, it will impact you guys only. If you are facing any challenge, please let us know. Okay. Adarshi, are you hearing call? Adarshi, are you hearing call? He might be occupied. Uh, no worries. If this is the case, let me have a word with him. And if I don't think it's a bug. If it's a bug, we'll resolve it. I don't think it's a bug because at last you will be getting certificates only when you will upload the project. So till then, please do complete the certificate. Please do complete the courses so that at last you would be only having the course part. Sorry, the project part. Okay, so try to complete the courses prior to that. Okay, then we'll ask you to submit your project, create your project, submit your project. Then it'd be too hectic for you to complete the courses, then complete the project, then submit the project, and then get the certificate. So please do complete your courses right now. Do it as soon as possible. We are explaining you all the concepts. We are explaining you all the concepts. So even if you are, just reading it superficially, then also you will not be missing anything because everything is covered in these type of sessions. Okay, and still, if you find something new, please, we are continuously in touch with you. You can ask anything from us, and we'll explain you. Right? Oh, another course is showing. Okay, then it might be a bug. If it is in that case, let me you know Adarsh Anji is might be on another call. So as soon as he joins the call, we'll ask him to do this. Okay, guys, any other query, technical query related to mathematics, whatever we have studied till now? Yeah, sure, Jay. So, so can you explain what is underfitting? Yeah, underfitting is simple. Underfitting is something that you know that is not learning anything. Okay, mean it means that if your data is going somewhere and your model is going somewhere. Can you see this? If you can notice this, if you can see the screen, wherever the whatever the data is, model is trying to learn accordingly, right? It is actually adjusting its line according to the data flow. So this means that it is learning, and hence it is, if it is learning, it is not it's a good fit. It is fitting, right? But what if if you see, just sorry, what if you see something like this and your data points are somewhere else? If line is this and their data points are somewhere else, then this means that it is underfitting. Okay. Okay, Jay. Sir, in AI Skills Navigator in FICE, there is certificate credentials, so you can provide some coupons for that exam for credentials. No need of coupon, Chirag. Sir, what are the main checkpoints that we are needed to be covered during data visualization to get maximum insights from the data? In short, how to do I understand the data? Okay, so uh, main checkpoints during data visualization. Yeah, data visualization. There are no checkpoints such thing. Data visualization depends upon the data and the requirement of the stakeholder. Okay, for example, it's not like ki, uh, you have to create 10 graphs compulsorily, and by any chance you have it's your uh, guys, am I not audible? Can you just confirm? Am I audible, guys? And my screen is, yeah, audible, na? And my screen is also visible. Is shared, right? Camera is also working. Hi. Yeah. Perfect. Perfect. Then who was saying? Yash, please check your speaker. Okay. Nice. So, okay. Meanwhile, let me start the recording as well.
Recording in progress.
Okay, guys. So people were asking related to data visualization. So let me read the question one more time because most of the people now started joining. So what are the main checkpoints that are needed to be covered during data visualization? Who is asking? Darshan is asking. So there are no as such checkpoints. Okay. So it's not like they will ask you to, like, by any chance you will be asked to plot few graphs. No, it totally depends on the problem statement. Like if they are asking you to if they are asking you to show us the trend from past 10 years, for Amazon, okay, then nobody will actually plot a bar graph or a bar chart. Everybody will plot a line chart, right? So this is the reason. Like there, it's not like a the check or something. No, there is no checkpoints. Okay, it's like you need to first understand the requirement, what is the data, how's the data looks like, and then you need to understand the problem, like how I will solve this problem. Okay, and to understand the data, you need to understand you need to understand uh, the domain knowledge. Okay, you need to understand something about the domain, then only you will be able to understand the data. Imagine if I am a person who is totally unaware about the bikes. Totally unaware means what is this BS6? What is this CC? What is this mileage? No, I belong to some different world. I don't know what is it. I only know bike. I only know bike. I ride it, then I park it, then I sleep. Again I ride it, I park it, and I sleep. I don't know about mileage. I don't know about CC. I don't know about tire pressure. No. In that case, if that guy will be provided any data related to the bikes, he won't be able to give any sort of insights. So you should have a domain knowledge. Then you should have a clear cut understanding of the uh, problem statement. Then you need to have a clear cut understanding of the data that is given to you. Even if you have a good domain knowledge, but the data is not correct, then also you'll not be having a really good visualization and insights. So these are the checkpoints, I must say. Yeah, thank you, Darshan. So, Poojan Patel, sir, with the help of Collab, should we show the visualization as per Power BI? As per Power BI or like Power BI? See, like Power BI, okay. So, Power BI, okay. So, again, the visualization that you perform on Python, they are different from what you perform on Power BI. In Power BI, okay, let me make it very clear. What is the purpose of Power BI? The purpose of Power BI is to simplify the uh, insights that are there in data for the stakeholders. Stakeholders doesn't care about how you have coded it, about how the tables look like. There's a they cannot spend their hours to understand the scenario. They want someone to give them the dashboard so that they can get the thing right there. Okay, so Power BI they can use, but you have to create it and then give it to them. Okay, they just care about the presentation explanation. Yes, Raj, exactly. So but in Python, okay, but in Python, why do we visualize these data and all? We visualize this for the sake of the model. Okay, we visualize this for the sake of the statistical analysis, to do some hypothesis testing. Okay, to do some mathematics. We require Power BI. Oh, sorry, we require Python. Okay, Power BI is for the stakeholders, for some tech, for some non-technical people, those who want some business insights. Okay, business people. Okay, this is the difference. Just yes. Okay, then I think we can start. It's already two. It's already what is the time? 1:19. It's already 20 minutes, so I think we can start now. Perfect. So now let's start. Okay, first of all, let's continue with the thing that was going on previously. Let's continue with that. Okay, so where you were? So how much we have completed? Okay, so we were on lasso and ridged, right? So you guys don't know, doesn't understand lasso and ridge regularization. It's okay. Now let me explain you what exactly it is. And guys, this is one of the most important topic of machine learning, especially supervised machine learning. Okay, let's not say supervised. Let's take machine learning. And even if you will say it is the most important topic of one of the most important topic of AI, take it. Okay, not a wrong sentence. Take it. Okay, because lasso and ridged regularization, they are both, are really important to tackle the problem of overfitting. Okay, okay, both are important to tackle the problem of overfitting. Okay, so how it does? Okay, so how it does, how lasso does. So first of all, what is lasso and what is ridge? Okay, and how they basically solve the problem of overfitting. Okay, sure. Okay, let us try how to do that. So basically, let me open that file only. Yeah. Okay. So guys, this is the formula for, there are two, right? One is lasso and one is ridged. Okay. By the way, both are used to tackle the problem of overfitting only mainly. Okay. Lasso and ridged. Now, what is your loss function, guys? Can you tell me what is the loss function for linear equation? What is the loss function? What is the loss function for linear regression? Guys, what is the loss function for linear regression? No answer? Guys, am I audible, right? Am I audible? Model how works like good or bad. I am saying what is the loss function? Means mathematical statement, like mathematical equation. Tell me that. Tell me the mathematical equation. Sum of actual minus sum of predicted, basically. So one way or other, it's like this. Correct me if I'm wrong, okay? It's something like this. Okay? right? Is this a loss function? Is this a loss function? Everyone, is this a loss function? This this is a loss function, right? Guys, no reply. What is happening? You had lunch, right? You had lunch? No. Oh, that's why. Yeah, generally after lunch, people feel sleepy. People feel sleepy, right? After lunch. So you must be, energetic. Huh? Is high on lunch. Okay, Raj is commenting all of you. He thinks everybody is high on lunch. Yes, feel sleepy. Okay. Okay, it's good, guys. It's okay. But but most of the interviews these days they are taking place in noon time only. So we cannot afford us, to sleep at this time. Don't know the answer. It's okay. It's okay. So guys, this is the loss function. Okay. If you don't know the loss function, this is the loss function. Okay. This is the loss function. Okay. So guys, you don't know the loss function? Should I explain it in detail? Okay. 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 Got it. Got it. I thought you might know this. That's why I was explaining you Ridge and Lasso. Hey, it's okay, yaar. It's okay. No worries. Let me explain you. So guys, so basically what happened is, so basically what happened is the people, how do you learn things? How do you learn? You learn things by decreasing your errors. You by decreasing the number of mistakes, right? When you were kid, most of the things whatever you were doing, they were mistakes. Don't go there, don't touch this, okay? Eat regularly, eat good, sleep on time. Like this, na? Small errors. But now, most of those silly errors, they are not happening. Even if you are not sleeping on time, means it's your time, right? You know how to take care of yourself. So most of the errors are, they are not happening. Even some, if some error is happening, they are new. Not silly errors are happening, right? Okay. So basically, what exactly it is? So every machine learning algorithm has a loss function. Okay. Every machine algorithm has a loss function. And what is this loss function? Loss function is what was the actual answer minus what it has predicted. So basically, this is a loss, na? This is the error. What is the error? Error means, sorry, what is error? Error means actual minus predicted, right? This is the error. So now, what is our duty? To minimize this error. Minimize the error, right? Yes, Raj, I got your point. Actually, there are some students who doesn't understand the loss function. So right now I'm on loss function. Okay. First they'll understand the loss function, then I'll jump to last one ridge. Okay. Yeah, of course. Yeah, one upon n, of course. Okay. So minimize the error. So this is our duty. So so this is only, so what is this n equals to 1 to n? This is for all the data points. Data point number 1 to data point number last. Okay. And then dividing the number of data points. So this is our average value of error. And this is the average value of loss. So what we want? We want to minimize the error. We want to minimize the error, right? So just imagine this is the graph of error. Just imagine this is the graph of error. So you started basically training your model. So at the time of training, like initial training, your error was high here. And now gradually it has started decreasing. Right? Gradually it has started decreasing. And for different values, it is giving different value. It started decreasing, again increasing. Started decreasing. Okay. Again going normal. And then. So tell me the point. So tell me the point where. So tell me the point where loss is minimum. Can you tell me? Can you tell me where the loss is minimum? 1, 2, 3, 4, 5, sixth. Sixth point. Here's the losses minimum. So what is our target? Our target is to reach here. And don't you think it is nothing but global minimum? People used to say, sir, I have understood a lot of mathematics. Where to apply? Right? People say this, right? I don't know where to use the formula of a plus b ka whole square. Can you use here a minus b ka whole square? Right? So this is the logic behind it. Okay. Okay. So this is what we want. Now to reach at this place, now to minimize the error. Okay, to minimize the error, and but the scenario is to minimize the error. That is the one thing. The second thing is we want to minimize the error, yes, but not only for the training data. We want to do the same for the test data as well. But we are successfully training it till 99%, but we are unable to test it and get the same number in while testing with the same number. If this is not happening, what is the problem? The problem is overfitting. The problem is overfitting, right? If we are minimizing the error while training, but we are unable to minimize the error while testing, this is the overfitting problem, na? So now to deal with this overfitting problem, this is a loss function. Okay. So to deal with this overfitting problem, okay. Okay. What is the loss function right now? Right now, loss function is the loss function is 1 upon n sigma yi minus yi predicted, right? Whole square. This is the loss function. So what if I ask you, or I put more burden on you? What if I put more burden on you? For example, let me give an example. Suppose you are having exam of 100 numbers, right? 100 numbers. And now it's your duty to get the maximum number. To get the maximum number. So if you are getting right now, if you are getting 60, your error is 40. So now your duty is to minimize this. Now your duty is to minimize this. So you will try to focus on this number only. Okay, but this is creating actually this you have successfully trained it to 100% now while training, but while testing it is getting failed. You are unable to get even 60. You are getting 50. This is the overfitting problem. Means you are very well learning the all the examples, but you are not learning, enough to test yourself. I'm correct, right? Am I correct? That you are asked to solve 100 questions, you are only solving 60 questions, then 40 questions are remaining, but after gradual learning you got 100%. Now you have trained yourself 100%, but while testing you are again performing 50%. This is the overfitting problem. Okay, now to resolve this problem, what I will do, I will say, yeah guys, you need to not only fight with the while training, you you were fighting with these 40 numbers, right? And you were successfully learning, you were successfully trained yourself 100% while training. So now what you have to do is, now I will cut your marks by 10%. So if you are getting 60 marks, I'll cut your marks by 10, so you will get 50. If you are getting 50 marks, I'll cut your marks by 10, you will get 40. If you are getting 40 marks, I'll cut your marks by 10, you will get 30 marks. So you will say, sir, why you are adding this more 10 to our loss? Now, but right till now, in while training, we were getting 60. Now, if you will cut 10 more marks, we'll get 50. Then the total range will be 50. Like I need to score 50 more, na? Before this, I was scoring 60 and I had to score only 40. But now you are again deducting 10 more marks. You are again deducting 10 more marks. So now we have to achieve 50. And suppose if somebody is getting 40 marks, if somebody is getting 40 marks, you will again deduct 10. So he will only get 30 marks. Then he need to score 70 more marks. Why you are unnecessary putting pressure on us? Already we need to score 40 marks, right? 40 more marks to get 100. You are saying I will cut 10 more marks as a penalty. I'll penalize you guys. You are not scoring good. I'll penalize you. You are not doing certificates. I'll penalize you. So what will happen? You need to work harder. You will work harder, right? You will do the courses, you will complete assignments, you will complete everything. And where this particular hard work will reflect? In examination. Understand the analogy. This is the basic crux of Lasso and Rich. Understand the analogy. So if I'm putting more pressure on you, you will perform better. And this is it. Yes, I'm coming to you, Raj. Okay, let me complete this. Okay, so if I'm putting more pressure on you, so you will perform better. If you are getting 60, you need to improve 40. But what if I say I'll cut 5 marks? Then what will be your score? Your score will be 55, and now you have to score 5 more marks, 45 marks, right? So this is what we say regularization, right? This is what we say regularization, and there are two types of regularization. First is Lasso, second is Ridged. Means right now what you are doing, you need to cover only this error. You need to cover only this error. Where is the error? Yeah, here is the error. This is error. You are only working with this loss function, right? 1 upon n sigma y minus y predict whole square. You are only dealing with this. But now what I will do is, I will add one more term. I will add one more term. I will add one more term. And that term is something like this. Lambda, right? I'll add something like this. Lambda b, or you can simply say w mod w simple. Either, okay. So what will happen is, right now, sorry, till now you were only dealing with this, but now I have added few more error to this, and this is called lasso regularization. In lasso regularization, I add mod w. Okay, means you are dealing with the error, now you have to deal with this extra penalty. Okay, first thing. Second thing, ridged. Ridged. What happens in ridged? So the basic thing is same. 1 upon n sigma y actual minus y predict. Y predict you can write like this. Y predict whole square. This was normal. This was there as well. This was normal, right? But additionally, what you will do? Additionally, you will put lambda w square. So in ridged, what we do is, we actually put square, and in lasso we put mod. And what is the purpose? Purpose of both. The purpose of both is to reduce the chances of overfitting. Right? So this is the purpose of lasso. Now, yes, okay, we have understood that along with the error, you need to take care of extra entity now. You need to take care of this extra entity. But why two? And how these two are different? We need to discuss this now. How these two are different. So guys, do you remember in last session, in feature engineering, we had a talk on feature selection? Do you remember? Do you remember? We had a word on feature selection, right? Okay. Feature selection means some features are important, some features are not important. So we need to decide which feature we need to choose, which column we need to choose for our model training, right? Okay. So if you are, see guys, okay, I know that on screen there is some mathematics going on. I completely understand that part. But if you are not interacting now, if you will not interact now, then definitely you won't be getting anything, to be honest. So if you are having any sort of issue, let me know. Okay, I don't want you to just complete this anyhow. No, at least understand something. Okay. Oh, it's okay, we will reduce something from classification part, it's okay. But if you are not understanding this, then definitely you will lose something. Okay, so please try to interact as much as possible. Okay, if you are not understanding this, let me know. If you are unable to understand this, let me know. Please do. Okay, I'll explain you in different way. Okay, so now the difference is, this ridged This wrist, this wrist, okay, let me write here now. This wrist, lambda, okay. This lambda is regularization parameter, okay. This lambda, just like a learning rate. So now, what this ridge does, ridge actually tries to penalize all the features equally. It tries to shrink the power of all the features, tries to shrink the, the involvement of all the features. This is the first thing it does, okay, because it has square function. And what square does, it exponentially, it increases the power. Then how it is penalizing? If just by a single number, if you are just increasing from 2 to 3, it will penalize 2 square 4, 3 square 9 by 5 points. And if you are just putting 4 square 16 by 5 points, right? And if you are putting 5 square 25 by 25 points. So now your model will be more cautious, because it does it do understand that after all you need to minimize the loss. And if it will increase by a single point, then what will happen? The loss function will increase drastically, and hence it will take care of all the features equally, because it has square function, okay. It's like, the penalty. What we do with the penalty, we afraid of penalties, right? We don't want penalties, okay. Even if you are a stud, still we avoid penalties, okay. So so this is the reason why we are putting this pressure. Even if it is increasing weight by 1% or 1 point or 2 point, then the square, the exponentially, the effect will come. The exponential effect will come. But in this is the case. Now, what is the case of second? Lasso. In lasso, what is happening? In lasso, basically what we are doing, we are just using mod. So it's better, right? We are just using mod. So how it is beneficial then? That it is beneficial because it has a simple threshold. So if we just put a threshold, okay, just bt, if it is more than that, then we will give value 1, okay. If it is less than that, then we will give the value -1. And if it is 0, then 0. So what is the, what is the outcome of this? The outcome of this is lasso is used for feature selection. Means if it finds that, hey, if it finds that, hey, uh, this particular feature, this particular column is not actually significantly adding any value. The value threshold is 5 points. It is adding only 4 points. Hey, ignore, remove this feature. Put it 0. Put it 0. If it is below our threshold or equal to threshold, put it 0. So, ridge, the square one, it actually tries to minimize the context of all the features. It never put it 0, put those 0. But lasso explicitly put the columns exactly 0 if they are not adding any good value. Are you getting my point? So this is the difference between lasso and ridged. Okay. So this is okay. I hope you got my point now, right? I hope you got my point. Can I get yes, no, little bit, what? Okay. Only Darshan, only Shesh, only Hardik, only Vishwajit, little bit. Okay. It's good. Zeal is saying, can you, sir, can you repeat, please? What you want me to repeat? No. Okay. So the last one is, I said, there is ridged. There is ridged. Ridged is all about lambda, weight, square. Weight of what? Weight of the feature, square. Lasso is all about mod, right? So what mod does is, it actually, yeah, I'm tempting. What mod does is, what mod does is, it actually put, okay, for lasso, what we do is, we actually decide a threshold. We actually decide a threshold. Threshold of what? Threshold of importance. Means, if this particular column is not giving us this much importance, then we will remove it. Means, give value 0. Give w is equal to 0 in straightforward. Give w is equal to 0. Put the coefficient 0. Okay. And if for some columns, if the coefficient will be 0, means it will be completely removed. Yes, and this is used for feature selection. Yes, Chirag. And if for some coefficients, if they are not adding much value, those columns will be getting 0 coefficient, means no involvement in the model training. And this is how feature selection works in lasso. But in ridged, it's not about feature selection. Feature selection is not happening there. It is actually, what is it doing is, if you are, okay, if you are giving less value, you will be penalized more. If you are getting more value, you will be penalized less. So it is actually treating all of them equally. Okay. But what, how, this is doing, but how this is doing, it is actually doing, like this lasso, it is actually, you know hardly penalizing it. Okay. If you are not crossing the threshold, you will be penalized. Coefficient will be 0. Yes, exactly, Chirag. So now I hope you have understood. Thank you. So now let's first of all complete this part. So see, this is how we have trained this with the lasso residuals and this residuals. Okay. And we have tried, like, how lasso residuals is working with the chance of admit, this residual with chance of admit. Okay. Then it's a QQ plot of normality. Okay. So this is what it is. Okay. So here you can see, you are getting you are getting r square here, right? For lasso, the r square is, it's negligible, but for ridge it is around 80%. So means for us, ridge is working better. right? Okay, okay. So this is how it is working. Nice. Okay, and then there is a decision tree. Okay, decision tree is like this, and how much accuracy it is giving? It is giving us for train it is giving us 85%, but for test it is giving us 74%. And the root mean square error is 0, 0.005. Okay. So this was all about the linear regression. So in linear regression, you have learned a lot of things. Now let's jump to logistic regression, means classification task. Okay. So in classification task, what we are doing? In classification task, we are taking loan type study. Okay. What is the problem? Problem is Loan Type is an online platform committed to delivering customized loan products to millennials. They innovate in the otherwise dull loan segment to deliver instant flexible loans to customer friendly terms and salaried professional businessmen. Okay. The data science team at Loan Tap is building an underwriting layer to determine the credit worthiness of MSMEs as well as individuals. Loan Tap deploys formal credit to salaried employees and business four main financial instruments: personal loan, EMI, free loan, personal overdraft, advanced salary loan. This case study will focus on underwriting process behind personal loan only. Okay. So if you have understood, good. If you are not understood, then also good. Let me explain you. So Loan Tab is nothing but it's an online platform. It gives basically four types of financial loans. But here we will only take personal loan. Means we will only talk about the individual people. Okay. And what is our target is? Our target is whether we should give loan to that person or not. Okay. On the basis of what? On the basis of these details. Okay. We have these details. So we have the detail of term, means the number of payments of the loan. We need to check the interest rate, the installment per month, how much it will give, the grade. Okay. The subgrade, and then the what, employee title, designation, the employee length. Okay. Means basically I think experience it is. Yeah, it is experience. And then home ownership, whether it is the home or not, annual income, verification status, issue ID, blah blah blah, and all these things. Okay, okay. And the basis of this, we will basically clarify that whether one should uh, be given loan or not. Okay, it is as simple as this. So you can see. Okay, just a second. Where is the? Hmm. Okay, is it not there? Okay, it might be in the different data set. It might be later. Okay, no worries. Chalo, let's start. So then again, we started with the info. We started with the df.describe. Okay, then we started with df.describe for the object columns. Okay. Application type, purpose, title, loan status. Mm, okay. So this is a problem statement that given a set of attributes to of an individual, determine if the credit line should be extended to them. Okay. So what should we do? We should extend their credit line or we should not. Simple. On the basis of that, we will recommend this. Simple. Okay. So now, okay. So this is the data that covers 3,96,000 rows. Okay. in the linear regression we have covered only 500 rows, but it's a little bit nice data, approximately 4 lakh rows. Okay, then we checked for null values, so we can see 22,000 null values, 37,000 null values. Okay, but hopefully there were no duplicates. So what is the unique count? This is the unique count. Okay, you can see all these details carefully when I'll give you this Python file. Okay, chalo. Then uh, yes, so I actually divided this home ownership column to different categories. Okay, and I tried to get the count of it. So okay, so for mortgage, there are over around 2 lakh people on rent. For means 2 lakh people has given their home ownership on mortgage. Mortgage means like collateral. So on rent there are around 1 lakh 59,000, and then own 37,000, and others are 146 people. So this is what we have analyzed. Now let's directly jump to outliers. Okay, so this is the outlier. Okay, so this code is basically written to detect the outlier and then remove the outlier. Okay, okay. First what we have done. First of all, we detected. Okay, sorry. Yeah. First, what we have done. First, we detected the interquartile range. Okay. If open account is below or above this, this will be considered as outlier. If revolve utility is below 124 and above 1068, above that, we will remove it. And same with for total account. Okay. Now, okay. So this is what we analyzed. The data frame shaped after removal. This is the after removal of all those outliers. Okay. So rows with open in range with this removed. Okay. Nice. Okay. Okay. Now we are using C. Do you remember? I explained you this formula right now. Do you remember I explained you this formula? Right? Okay, okay, I can see some questions. Sir, one opinion from your end regarding project at the end of session. Yeah, sure, Raj. Sir, the name is logistic regression, but why predict classified values? You are asking, the reverse question. Uno reverse. The question should be like if it is giving the classified, classification, if it is solving classification problem, then why it is called logistic regression? It is called logistic regression because it is actually uh, predicting and you know it is actually working on numerical concept. Means at the back end it is regression only, but after after output, like in output it actually gives what? It actually gives probability. Okay, so that's why it is regression. Okay, nice. So now this is what we have discussed in the first half, interquartile range. So see what is happening. So first we calculated the quartile 1, then quartile 3, then we calculate IQR, then lower bound, then upper bound, and then we are counting on the basis of this. Give me the columns that are lower than upper bound. Give me the columns that are above than upper bound, and give me the sum. Okay, and then give me the outlier percentage. Outlier percentage means calculate the total count. Okay, see this is the total count. Okay, total count means total number of rows, and outlier count is the count that are outlier. Okay, and then print this. Okay, so this is how it will come. So for loan amount, Total count is 190, that is 0.05. Interest rate 3762, again 0.95%. Okay. Public records. So it is 14% of the data. Okay. So now, okay. So now, what we are doing, okay. So again, calculating outlier percentage for other columns. Oh, okay. So before that, I think we have removed some outliers. Yes. Huh. See, so here we removed some outliers. Okay. We have kept few outliers. Okay. And after this, we again perform the same calculation and we saw some, see, for loan amount and interest rate, it is zero. So we have actually removed the outliers for few things, for few columns, and for others, it is still same and or reduced. Okay. Okay. So, and one more thing, you might ask, say, hey, why you're not removing this 45,000 outliers and 57,000 outliers? The reason is simple. If we'll remove this, so approximately we will loss of 1 lakh crores. That is 33% of the data. We cannot afford it, right? So this is the reason. First, secondly, not every time is we required to remove the outliers. If your outlier is 14% or 11%, it means that it is a general trend, so you cannot remove it. Okay, it's not null. That it is not making any sense. If you have this many outliers, then it deserves to be there. Okay, nice. So okay, so then we started doing some bivariate analysis. Okay, this is how the data is distributed. You can just see it. See, this is the loan status, how many of them are fully paid and how many of them are year wise. Year wise. Okay, how many of them were fully paid, fully charged off, whatever. Okay. 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 So okay, now there is a the bivariate or multivariate count plot of all the columns one by one. Guys, one thing, there's a mistake. Never ever plot your graphs like this. Count plot for terms. Don't say like this. Instead, you should write here not a count plot. You should write like the to, the total count, or the total number of data points in term. Yeah, total number of terms. Yeah, total data points, something like this. Don't use this count plot, or don't write the name of the plot. We can see it's a count plot. We can see it, right? So no need to write it. It's a count. Even you can just change this as well. Okay. Okay. Nice. Okay. Then we have done some more analysis. Then we started some bivariate analysis. Okay. Okay. So then we did some more analysis. Okay. We started checking the distribution of different columns. Okay. So somewhere you can see they are following normal distribution. Somewhere it is also following. It is a little bit skewed. This is also a little bit following. Okay. This is not following. Now we will start handling skewness. Okay. So now we'll start removing some outliers. So here you can see some min max values of outliers. Guys, if you think that we are going a little bit fast in this Google Colab, because we are only having 1 hour left and we cannot, just read each and every code. So what I'll do is I'll give you this Python file, and you please do read by yourself. Do try to uh, uh, remind remind yourself. Do try to recall all the concepts that we have studied about data analysis in the very first session, in the data analytics session. Try to recall something from today's session. Try to recall something from previous session. Okay, so this is what you have to do. Okay. Okay, so you have not understood few topics. Okay, Prakash. So if you are unable to recall those, please let me know. I'll explain you here. Okay. Okay. Chaliye guys. So now let's start something, directly our model part. Okay. We have a lot to do still. Okay. Now they are checking for the normality. Okay. Treating null values. Okay. Now we have few points. Okay. Now let's start understanding the code part. Okay. Let's start understanding the code part. So, can you tell me what is this SMOT? What is this SMOT? Without actually doing Google and all. Can you tell me what is this SMOT? Do you guys aware about this concept? SMOT? Okay. Nice. Okay. Actually, most actually last class I asked few people, do you know this concept? Do you know what I am teaching? And most of the people said, yes, sir. Yes, Aman. We know what you are showing us. We know already. So that's why I thought like I can skip few things. Okay. And suddenly, so please guys do let me know if you are not understanding anything. Okay, this might be possible that I directly skip this mode. Okay, because for some people it is a normal technique, but for some people it might be new. Guys, okay, so few people are saying that sir, today's topic is little bit complicated. So guys, topic are not complicated, it's like they are new. Yes, yes, Vishwajit, thank you for saying this. It's new, right? So as they are new, so means, okay, if you are if I'm introducing any concept like SMOT, if I'm introducing any new concept like regularization, if I'm introducing new concept like R2 score, okay, this means that if even if you're not understanding here right now, it's okay. Please do note these terms and try to learn it from somewhere. What to do for learning that all topics get the job? Okay, Chirag. Okay, what to do for learning that all topics? What to do or where to do? You're asking where, right? Where we do learn. Huh. It's okay. See, acha. People are saying okay, Manas is saying we understood the concept but not the coding part. It's okay. Code doesn't matter. Code doesn't matter. Okay. If you are not understanding code part, it's okay. You need to understand what is SMOT. Where do we use SMOT? That's it. No need to try to understand code part. It's okay if you're not understanding code part. You can take it later. But try to understand the concepts. Okay. Try to understand why regularization is happening. What is the difference between lasso and ridged? This you should understand. Okay? It's okay. It's okay if you're not understanding code, but it's completely fine. I know, like guys, if even if I'll see this like this, na, like just scrolling, so even I'll not get anything. It's okay. That is not a problem. Okay. You want today's topic names, so you could have you could have written when I was explaining. It's okay. Like I'll put this in Telegram or something. Okay, no worries. Or on recording you will get. After all, recording is there, right? So let me start. Let me start. So what is this smooth? And guys, one more thing. If you guys have noticed, just now, like I have got, I'm getting started with the training part, and just now I am doing, the train test split. Okay, see, I'm just splitting the columns y and x. Then I am actually doing train test split, and right after that I'm doing smooth. Means smooth is something that is a foundation. It comes in the foundation of model. Okay, I'm not doing in after training part or after testing part or after deploying part or before deploying part. No, I'm doing it right away in the starting only. This is my third step. See, this is my first step. Okay, this is my second step, and this is my third step, right? So means this is important. Okay, now how this is important? Let me tell you. So what happen is, guys, what happen is, just imagine. Okay, just imagine the data that you are having. Okay, the data that you are having is not enough. Okay, the data that you are having is not enough. So what you'll do? Okay, so what you will do? You will try to get data if you are not having that data. Okay, so the problem is many times you are not having the balanced data, right? Many times what happen is you never have a balanced data. So what you'll do? Okay, so what you'll do? You need to balance it. Now what do we mean by balancing? What do we mean by balancing? So the balancing is, like, suppose there are two different categories, and one category is 70%, second category is only 30%. Okay, okay. One category is 70%, one category is 30%. Then what will happen is your model will think, okay, let me make it more clear. Suppose you are creating a model for spam detection. Suppose you are creating a model for spam detection, and you are having a data where 90% of the mails were good, 10% of the mails were a spam, and you started training on that data. Okay, let me create the problem statement one more time. You are building a model for spam detection, whether this particular mail is a spam or not. Now, for that, you trained a model, and the data was like 90% mail were, 10% mail were spam. Will any mail is coming, any mail is coming, if even any mail is coming, even if you will just put it in category of good mail, you will get 90% accuracy. Only 10% of times you will get face error, right? If there are 90% in the of mail are good in the data set and only 10% of mails are bad, then model will think even if I am putting all the mails, means if you are giving me thousand of mails, Aman, you are the model, tell me which mail is good, which mail is spam, and I'm marking thousand and each and every mail, the whole thousand mails as good. In that case as well, I will only get 100 mails as wrong marked, but still 900 mails will be correct, right? Without doing any calculation, without doing any process, I can simply mark it correct, 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 good mail, good mail, good mail, good mail, green tick, green tick, green tick. If I'll do this part as well, then also my 900 mails will be correct. Only 10% mail, means only 100 mails will be wrongly marked. Okay, what is the issue? But do you think there is any learning in this? No, no, right? There is no learning. Hence, this imbalance of the data set is a problem. This imbalance of the data set is the problem, right? Okay, okay. So, guys, now if that is unbalanced, what will happen is your model will try to learn that unbalanced data set only, and it will impact your model accuracy. It will not perform better in real life scenario. What if I'm giving 10 mails and or a spam, and it is marking 9 mails as a good mail and only one mail as a wrong mail, but in actual reality all the mails were spam, then our model will fail. Yeah, similar to average. To resolve this problem, we have SMOT technique. What is this SMOT technique? So the full form of SMOT is synthetic, minority, oversampling, minority oversampling technique. So this is the oversampling technique. So now we have two options. Now we have two options. Either we have 1000 data sets, 100 of them are spams, 900 of them are good. So we have two options. Either we take all the 100 spams and along with only 100 good mails, and let's forget 800 good mails, just balance the data set. But what will happen? We will only end up with the 200 data points, right? Only 200 data points. Now the second option is this is called undersampling, means you are cutting down the you are cutting down the data. But second approach is oversampling, you are cutting down the samples. But the second option is oversampling. What if I increase the number of the minority, right? Then what will happen is both will come at the same level. Means What if there are 100 100 meals are were spam, right? Let's make it 500. Then 500 will be good, 500 will be not good. 50-50%. Is it good? Right? So without doing anything much, we have maintained the length of data set. And that's why it is called oversampling technique. So synthetic. Now, what is synthetic? Synthetic means we are adding the data for minority, but that is not reality. That is synthetic data. That is not real data. Means by understanding the pattern of other data points, we are creating some data from ourselves. That is why it is called synthetic data. Okay? Means we are not adding the real data, right? If we have the real data, then why we are doing smooth? We are not having the real data, that's why we are doing smooth. So what smooth will do is it will try to understand the pattern of all the spam data points, and it will add those data points till it is balanced. Till it is balanced. Yeah, sure. So yeah, I'm repeating. So basically, okay, let me write it. Let me write it. So so you are having 90%. So what smooth does is smooth creates, okay, synthetic data. Synthetic data means data it creates, it doesn't exist, it is creating the data so that both will be on same range. Both will be on same range. Means not range, means both will be on same number. Right? So this is the reason why we have smooth. Synthetic minority oversampling technique. Okay? Nice. So, okay, just a second. I have one image as well. It would be good if you will understand that. See, mm, okay, okay. See, can you see this? So what is happening? This was the original data. See, and now what we have added? We have calculated and added few red data points. These data points are completely synthetic. They are not really actual data points. But then we painted green. Means now we have increased the data number of data points. See, so this was original, and now this is resampled. This was original, this was resampled. We had one more option. Either we can just remove some blue dots and just make it as equal as the green dots. Then, but the problem is it will be a data loss. So instead of this, we actually oversampled the data. We have added some data, synthetic data points, and we done this part. Hope you are getting now, right? So this is what oversampling does. And then again, it is basically standard scaler, means standardization, right? Standardization. Okay. And then again, we have logistic regression. We have marked the iteration. Okay. The class weights are, see, okay, guys. So now, if we are doing smooth, so there are two options. We can do smooth as well, or in the code only, in logistic regression, there is a code where we can simply say class weight is balanced. Means if you are not doing, this mode problem, if you are not doing this mode technique, if you are not performing this technique, you have other option as well. You can just put class weight equals to balanced. What will happen is, it will treat the columns where with the minority different and with the columns with majority different. Means it will decrease the weight of the majority and it will shift some weight to minority to make it balanced. To make it balanced. Hope you're getting. So this is also a way to get the things done. Okay, nice. Okay, so now see, we are doing we are doing some testing some validation data set. Okay, validation probability. Okay, well, first we are checking validation set performance, then we are checking test set performance. So we are so this is where we have used validation data set. See, okay, nice. Okay, so here we have numbers. So in validation, the precision was 90, recall was 80 approximately. Okay, here it is 42 and here it is 65. Okay, F1 score is 84. Okay, so it's good, I think. The score is good. Here is also almost same. Not much difference. Not much difference. Test performance is also, similar to the the validation performance. Same performance almost. Okay. Then this is AUC ROC curve. We understand this AUC ROC curve. You know, in next class. Okay. Whoever will take the next class, he will take this. Okay. Right now, I want you to see one thing that I'm just telling you. See, this is what I wanted. See, so this is something that you need to understand now. Okay. So now this is the importance curve. Importance curve means importance score. So now what we have done is, we have given the score point, means we are not given, we have calculated using this, you know, this feature. Okay. Okay. So we have created this, and now we have actually given the score to each and every column based on its performance. Okay. How that, who is actually important and who is not. So we can see there are some actually features that are really important, and there are some features that are not important. Okay, so what we can do, we can simply say, okay, we can simply remove those columns that are not important. Okay, and then what we have done, we predicted. Okay, what we have done, we printed all the values, all the relevant values. Okay, like this. Okay, and then we try to calculate the probability. Just a second. Yeah, again, feature importance. These are the columns, okay, and these are the this is the feature importance, okay, that we have calculated. So if you want to remove few columns that are not important, okay, so either we can remove the column, or we can, what we can do, we can use PCA, principal component analysis, okay, means dimensionality reduction. We can reduce the dimensionality while retaining the information. Either way you can do. See, there are a lot of features now. So instead of using all the features, you can reduce some features, reduce those features. It's okay. Okay. So this was the thing. Okay. Now, now there was one point that we missed in linear regression, and that is nothing but, nobody asked me. I don't know why, but there was one thing that we missed, and it was R2 score. Do you know, guys, what is this R2 score? What is this R2 score? Threshold we put explicitly? Yes, we put it. Uh, Nice question, by the way, Chirag. Uh, there is a uh, there are some methods for that we can use to get the correct threshold as well. Okay, they are some advanced methods, but yes, there's an option to calculate the threshold. But generally, in those methods as well, we put it explicitly only. Okay, and using some programs, we can just get the best threshold. We put multiple threshold, we put a range of threshold, and then we multiple times, we run the model, and we get the graph, and we get the best threshold. This is what we do. So before this, do you know, guys, what is this R2 score? What is this R2 score? This R2 score is one of the metric. Okay, this R2 score is one of the metric to check whether our model is working fine or not. To check whether a model is working fine or not. This is one of the metric. Can anybody tell me what is this R2 score? Guys, I am expecting the answer. Guys, I'm expecting the answer. Do you know how to score? Say yes. If no, if you don't know, say no. It's okay. Yeah, evaluation for regression. But what is it? Like, how do we evaluate it? What is R2 score? What is the formula? What is the purpose? Regression analysis? Maybe R2 score tells us how well a regression model fits the data. Yes, it tells, see, it's a evaluation metric. It's a evaluation metric, right? So definitely it will tell you something about the model fits, model fitting and all. But what is the formula? Like, for example, we have mean absolute error. So mean absolute error is nothing but, the actual minus predicting mod divided by n, sigma. Mean absolute error. Mean square error, just put, instead of putting mod, put square divided by n and sum. This is your, mean square error. Root mean square error, and then we underroot it. Simple. So what is this R2 score? This is what I want. And then adjusted R2 score. First you will understand the R2 score, then automatically you will understand what is adjusted R2 score. No inputs? Okay, no worries. Yeah, thank you, Swami. So let me show my notepad. Let me write the formula. Okay. So I think I have pasted somewhere. Yes, here it is. So r square is nothing but this is your r square. Okay. So r square is nothing but 1 minus residual, sum of residual and sum of total. Okay. Sum of squares of residual, sum of square of total. Simple. Nothing much. Okay. So this is how you calculate the r square. So now how these both are different? How these both are different? So this is different because sum of square residual. Oh, sorry. Okay. Sum of square of residual means y minus y predict whole square and then sum, right? But sum of total means y actual minus y average. Means basically it's nothing but we are comparing our model with average model. We are comparing our model with an average model. For example, when you do not know the answer, what do you do? When you do not know the answer, just imagine there are some people. Okay, what if I just ask, what is the average height of your classroom? Sorry, yeah, what is the average height of your classroom? Then you will say, to try to find the answer. Just try to calculate the average answer. Okay, even if I'll just ask you, hey, can you guess something like on any topic? You will guess a topic that is that is average. Average means that you will first think, okay, I should speak a topic that can be understood by all. Means a topic that is average. It should not be too low class, it should not be too high class, otherwise nobody will understand. So let me talk on a topic that is average. So comparing our model, whatever it has predicted, whatever it has predicted with an average model. So this SSTOT, SS total is nothing but it's an average model. Average model. Okay. This is the average model. And now this is our actual model. So the process of comparing your actual model with average model is R2 score, yeah, R square score. I hope you're getting the point. Okay. And then when we calculate this, if we are getting 1, that means good. If we are getting 0.5, that is okay. Yeah, medium, okay. Huh? If you are getting lower than that, that means that means your model is not good. Yes, it is poor. Yes, good. Good. Now you are getting the point. So now if you can see here, okay. So Okay, if your model is less than this, means it is not even learning average of your model. Okay, so this is the scenario that you need to keep in mind. Okay, okay, good, 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 good. Okay, so actually I was reading one article on this. I am finding that once I'll, okay, 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 okay. Hmm. Yes. Okay. So if basically if you are getting r square as 0, okay, then your model is as good as your average. For example, okay, let's take it 0 means, and remove this as well, as okay as a mean model, right? Okay, you got the point, right? As okay as the mean model. And if by any chance, if you are getting negative value, okay, less than 0, if you are getting less than 0, this means that you are even worse than mean model. Worse than mean model. Okay. So this is the scenario that you need to understand. Okay. Okay. This you need to understand. Okay. So this is why this R2 score is so crucial. And in industry, if you are getting R score 0.9 above, 0.9 or above than that, it's a good fit. It's really a good fit. Okay. If you are getting 0.7 between 0.9, then it's a okay, nice, good one. But if you are getting lower than that, then it's a moderate. And if it is 0.5 less than 0.5, then it's a very poor fit. Okay. And if you are getting less than 0, that is totally unacceptable, right? It is totally unacceptable. Okay. So this was the thing. And now you can see if you are getting a high R square, see, this is how your model is behaving, right? This is how your model is behaving, right? But if your R square is too low, means too, even it is not too low, it is just getting, you know, zero point 0.2, okay, approximately, and see the difference. The difference is noticeable, right? So this is how your R2 score matters. Okay. Why I pasted these two graphs? Okay. I hope you got the point, guys. Everyone. I hope you got the point. Yeah. Question is, can a model have low auto score but still be useful in what real world scenario? No, no, no. This is what I'm saying. If you are having R2 score lower than 0.5, it is not considered as a good score. It's a bad score. And if you are getting a negative R score, R2 score means completely unacceptable. Okay, they might fire you. Yes, sure. I'll request Adarshi. I don't know like whether he is here or not. He is not here. Okay. Yes. I was just about to give you the attendance link. Guys, please fill the attendance link properly. I'm just sending you. Okay. And guys, please do fill the feedback form as well. If you think like if I've done something good, okay. If you think I need to improve something, please let me know. It would be a great thing for me if you will give your feedback. I need your feedback. Okay. Please always give the feedback because on the basis of your feedback only we learn the things. Okay. Please do fill the feedback form. Yeah, I'm sending. Oh, I'm so sorry. I was see. I have shared both attendance link and feedback form. Please do fill the attendance link. Please do fill the attendance. You know how to do it. Yes, guys. Now tell me if you have any sort of query, any sort of challenge. Tell me. Any challenge, any issue not received? I'm sending. Everyone, please fill the feedback form. If you have any doubts, please tell me. Sir, can we divide independent features into two or more than two parts like major features, minor features, and then train the model accordingly? How will it help you, Darshan? Even if you will divide your features major, minor, how will it help you? Yeah, Viren. Yeah, even I missed you. You are not there in the first half, I think. You are there or not? No? Yeah, I'll share the recording. No worries. Please do attend all the sessions, guys. If you are unable to get something, please let me know. Okay, I'll just I'm resending all the links. Don't worry. So please do attend all the sessions. Please do complete the courses. Okay, on time because when we'll start giving you the projects, you won't get time. Please do complete it before that. Okay. You will get the link on Telegram. Okay? The file on Telegram. Uh, Only 50% from today's session, but it's good because it shows first and it's complicated from my side. Yeah, Chirag. Actually, see, it's not complicated. Yeah, it's not complicated. Let me be very frank. If whatever we all are actually teaching you, I learned all these things in my bachelor's and master's collaboratively. Okay, okay. Then I got to know all these things. Okay, so if you are getting these things in just few hours, please don't hesitate to ask any questions. Okay, please don't think like these things are complicated. These things are not complicated. So my main why we are taking these sessions, why we are taking, the purpose is to give you guys some concept so that you can read it by yourself through MS Learn, through Google. This is the main purpose, right? There is no limit of knowledge. But if I am teaching you R2 score, by yourself you can understand adjusted R2 score. If I am teaching you R2 score by yourself, you can just Google adjusted R2 score. Or if you will only understand, just search R2 score now, automatically that it will recommend adjusted R2 score. Automatically. Learn it. Read the articles. What is it? How it is helpful. So we cannot cover the whole degree in these few hours. Even it is a internship of of 2 3 months, but still this is not enough, right? So please do try to understand from the point of view that it is not complicated. Okay, it is not complicated. Yes, it involves mathematics. It is okay. It's all about mathematics that you need to learn. Okay, okay. You are also machine, right? Can you suggest a good book of ML based on the math of theory? Hmm. Yes, I can. I can. Actually, I need to open my laptop. Means my one more laptop I have. Okay, let me see. I do have book. Okay. I do have the some of the book that I can just share you. Okay, you can try those books. Okay. Okay. So lot of books are available. You can just try anyone. It's good. Okay. You can try this one. Uh, okay. Like actually, there are so many books. Okay. O'Reilly. Okay. There are so many books from O'Reilly, but you can try this. Okay. I don't know like whether I can just put the screenshot in the chat or not. Let me try. Let me give you a book. No, I am unable to get it. It's okay. Chalo, let me share my screen. Yeah, see. You can please, if you can purchase it, do this. Do purchase this. Okay. This is good. I have this. Okay. This is good, and one more. One more. For your statistics. It is not showing here. Okay. Oh, it is also of O'Reilly only. It's also good. Okay. Hmm. Let me search with Yeah, this one. Okay. This is for practical. This is for statistics. Okay, and that was for machine learning. Okay, please do purchase these books. It's good. You have this? Nice. Yes, guys. So that's all. Thank you, everyone. If you have any doubt, still I'm having. I can be here for 2 minutes more. It's okay if you have doubts. If you are not having doubts, then we can close the call. Yeah. Thank you so much. Thank you. Thank you. Thank you, Z. Thank you. Thank you. Yeah, Dhruv, please share your problem. What is the issue? Can you show book again? Yeah, it's of O'Reilly. Like I can type the name. Okay, you can try O'Reilly statistics for data scientist and machine learning for data scientist. Okay, you can see the name. I have shared in the chat. Yes. Thank you, everyone. Please, please check above messages. What happened? Okay. Any deadline in finishing Microsoft Learn course? Yes, absolutely. Drupal. Okay. So absolutely, this is the deadline. Please try to do it as soon as possible. Even because before 31st, we will share the problem statement, and we want to close everything till 31st. Most of the things we will close on 31st. They might give you few more days, but why to ask for few more days? Let's get the thing completed. Yeah. Yeah, you can get a Google Form. I'll put this. I'll just give this to Adarshi, and he'll put this in Telegram. Okay. So the project of ICE and the college, it same and how we start our project. So the project is right now it is not shared, guys. It is not shared right now. We'll share the problem statement, domain, and everything, whatever is there. Okay, that you can just try. Is feedback from necessary to fill as links and Linux are not clickable? Can can't open but can open attendance. Yeah, Drupal, like it's up to you. Like attendance is mandatory. Actually, feedback form and attendance link both count as attendance. Okay. And personally, I also want you to fill the feedback form. You can fill it through mobile as well because it will directly will I'll be able to see that where I can improve. Do you want me to add some more things? Do you want me to reduce some things? Just please fill the form. कि 31 मार्च के पहले माइक्रोसॉफ्ट कोर्स कंप्लीट करने हैं उससे भी पहले कर लोगे तो अच्छा रहेगा. Okay, please try to do it before that. We got 5 problem statement already. Nice then. Congrats. You have already 5 problem statement. Start working. Actually, I shared all the 5 problem statement with the team, so they might have shared with you. It's good. Sir, seen the form? Yeah, sure. So I'm resending the links. Yeah. See, I shared. Dhruv, sir, we have up one problem when we go to college assessment. The internal guide says told them to give the progress of student during the months. and this is very important. Hmm. Okay. Guys, if this is the concern, okay, let me put this to Adarsh ji. Okay. He will talk to your college management regarding this. Whatever is requirement, he'll do the needful. Okay. Okay. Let me put this to Adarsh ji. Okay. No worries. So I'll try my best to fill it out, but filled a few feedbacks only as they content, but I have to fill the attendance forms. It's okay, like if you have filled the attendance form, try to fill the feedback form for mobile, okay? Chalo, guys, thank you so much. Take care. Bye bye. See you someday. Okay, and please do try to understand. Most probably, unsupervised learning will be taken care by some other person. So please try to learn all those things. If you find any sort of issue, please let them know. Let me know. Okay, and good to see you guys. Thank you so much. Take care. Bye bye.
Recording